We have successfully made it to the last part of the quadratics unit. We're going to take a look at some more application problems today entitled Projectile Motion. The good news about this is that you get to use a calculator. So hit pause and go locate your calculator. Let's think about the way objects fly through the air. If you were to, in taking a look at the picture at the top, if you were standing on top of a building and you were going to throw something, the path of the object, if you think of throwing a ball, would go up and then come down. Same idea if you were standing on the ground. Okay, if you were going to throw an object on the ground, from the ground, the path would go up and then come down. Not a very good parabola I drew there. You also could look at a situation where you're standing on top of the building and you drop something. In this case, the object doesn't go up, it just falls down, so it makes part of a parabola. These are the three types of situations we're going to look at with these problems. And I will tell you, these problems make a lot more sense if you draw a picture to go with them. Number one, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. Upward velocity means the force behind the ball. It's nothing you have to know or understand. The 90 is just what comes into play in this equation. The negative 16 has to deal with gravity. They'll always give us the equations, though. You're not going to have to come up with the equations. The equation h equals negative 16t squared plus 90t gives the height h of the ball after t seconds. So let's think of our picture here, okay? You're standing right here and you kick, oops, let's try this again. Okay, let's draw our axis. Okay, you are standing at 0, 0, and you kick the soccer ball. When you kick the soccer ball, it goes up and then it comes back down. Let's think in terms of numbers here. Like I said, my starting is 0, 0. My x-axis, those are my t values. That's time, okay? So these are seconds, okay, that the ball is in the air. The y-axis, that's h, okay? That's height. That's height of the ball in feet at a certain time. Find the maximum height of the ball. Well, let's think about on our graph where the maximum occurs. We got to go back to the beginning of the unit where we learned about maximums and minimums on a parabola. That maximum occurs right there, and that point has a special name, if you can recall, and that is the vertex. The vertex has an x value and a y value. In this case, a t value and an h value. So to find the maximum height, that is going to be the y value of my vertex. Okay, so let's think how we're going to find that vertex. We're going to calculate this algebraically, and we're going to use our calculator. Thinking back to what we learned earlier in the year. To find the vertex, we actually find the x value first, and our equation that we used was x equals the opposite of b over 2a. Okay, my a value is negative 16. My b value is 90. So x equals the opposite of b, so negative 90 over 2 times my a value. So negative 90 divided by negative 32. Type that in your calculator. And that gives us approximately, let's round to the nearest hundredth, 2.81. So right there is 2.81 seconds. That's my x value. I want to know the maximum height, so I need to know the y value. To find the y value, I need to plug 2.81 into my equation. So to find my height, we're going to take negative 16 times 2.81 squared plus 90 times 2.81. Grab your calculators, type that in. You should get 126.56. So that's our answer for part A, 126.56 height, and this is feet. We need labels for all these answers. How many seconds will it take for the ball to reach the ground? Well, where the ball reaches the ground, my height is 0. So I'm going to set my quadratic equation equal to 0. Now we've learned 5 different methods this unit to solve quadratic equations. We've learned by graphing, by square roots, by factoring, by completing the square, and by the quadratic formula. Well, I for sure can always use the quadratic formula, but I could actually factor this one as well. I'm going to see if I can factor it. I have a greatest common factor of negative 2t. What do I multiply by negative 2t to get negative 16t squared? That is 8t. And what do I multiply by negative 2t to get 40t, or to get 90t? And that is negative 45t. All right, set each piece, set each of my factors equal to 0. That's an 8. T minus 40. I shouldn't have a t there. All right, let's solve the first one. Divide both sides by negative 2. 0 divided by anything is 0. And my second one, let's add 45. And then divide by 8. And we get t equals 5.625. Let's think about that in the context of the problem. The question was, how many seconds will it take for the ball to reach the ground? Does 0 seconds make sense? Well, yeah, because at time 0, my ball started on the ground. And 5.625, if you think about it, the vertex is the middle of my graph. So if I take 2.81, which was a rounded answer, and double it, that gives me my other x-intercept. We calculated it exactly and found it to be 5.625 seconds. Number 2, an apple is launched directly upward at 64 feet per second from an 80-foot tall platform. The equation for this apple's height, h, at time t seconds after launch, is h equals negative 16t squared plus 64t plus 80. Well, let's start by drawing a picture. So now we're standing on a platform. Okay, we're going to launch that apple up into the air, and then it's going to hit the ground. Okay, so it pretty much matches this initial drawing that's up here. This one's on a building here. This one's going to be on a platform. Find the maximum height of the apple. Maximum height is still my vertex. So we're going to set it up like part A of question 1. So I want you to find the x value of the vertex and then plug that in your equation to find the y value. Hit pause and then come back to check. When we found the x value of our vertex, we took negative 64 divided by 2 times negative 16, which is negative 32. Negative 64 divided by negative 32 is positive 2. 2 represents, we think of this as my x-axis, 2 seconds is where I reach the maximum height. Because I don't start at 0, 0, I cannot assume this is 4 seconds, okay? Because technically, my parabola, if I were to continue a line, that is where 0, 0 is. So 2 is not the center of my parabola, so I can't double it to figure out when it's going to reach the ground. So we have to legitimately set our equation equal to 0. We can't just double the 2. Okay, again, we've got our 5 different ways to solve. I'm going to try and factor this, okay? See if it's factorable. Those are some pretty big numbers. I could plug in my quadratic formula, but let's see if we can factor it. Is there a number that 16, 64, and 80 are all divisible by? Let me give you a hint. The answer is yes. They're all divisible by 16. And because my leading coefficient is negative, I'm going to factor out a negative 16. So then I'm left with t squared minus 4t minus 5 I can factor that trinomial further. So leave your GCF on the outside. What multiplies to negative 5 and adds to 4? That would be minus 5 and positive 1. Well, a GCF of just a number on the outside does not affect our zeros. So I don't need to worry about the negative 16. I just think about the solutions to those 2 pieces. Okay, what minus 5 equals 0 and what plus 1 equals 0. So it would be 5 and negative 1. So in context of my graph over here, this point right here would be at negative 1, and this point right here would be 5. And that makes sense because negative 1 is 3 units to the left of that, and 5 is 3 units to the right of that. So ultimately, 5 seconds we're looking for. All right, I'd like you to hit pause and work through question 3, all of part A and part B. Then bring it back to check. In doing the math for part A, you should see that the maximum height is 25 feet. That maximum height actually occurs at the top of the building. Okay, that's my y-intercept, which happens to be 25 in the equation. So mathematically, we plugged it in and should have gotten 25, but we could also see that from our equation as well. How many seconds will it take to reach the ground? We set our quadratic equation equal to 0. Because I do not have a b term, I could use the square roots method to solve this problem. So I subtracted 25 from both sides, divided by negative 16, square rooted, and got plus or minus 1.25 seconds.